All right, now let's take a look at carbon and oxygen. All right, so we have 6 electrons in carbon. I'll do those ones in red. And again, follow them in the same placement pattern that we had been doing. You'll see why very, very soon here. So put these two together. Now that valence shell is full. The first one holds 2. The second one can hold 8. But I only have 4 more to place because I already put 2 in. So I can put 1, 2, 3, and 4. And as mentioned previously, there are 4 unpaired electrons in carbon, which means that carbon is able to form 1, 2, 3, 4 different bonds. Carbon is an element that doesn't form an ion, but it still wants to get this outer valence shell filled up so it can be happy. Oxygen, 8 electrons, element number 8. We'll do these ones in blue. Same idea. 1, 2, 3, 4, 5, 6, 7, 8. So this has 2 unpaired electrons. So this one has 4 unpaired electrons. This one has 2 unpaired electrons. Oxygen is also an atom that tends to not form an ion. Yet, oxygen wants to get this outer valence shell filled up. Let's take a look at how that happens. When an atom cannot simply form an ion and gain or lose electrons to fill its outermost valence shell, it can do something. It can share electrons between 2 atoms. And that forms a bond between those 2 atoms. Let's take a look at how that can occur. Okay, so we'll do carbon again in red. We'll do electron this time in blue, or oxygen in blue. And we know that carbon has 6 electrons. So I'm going to put those in here. 1, 2, 3, 4, and then there were 2 more, right? 5, 6. And oxygen had 8. So I'm going to plug those in. We'll make this one will be carbon, and we'll make this one oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now I have plugged that in. That one is oxygen. We'll also make this one over here oxygen as well. 1, 2, 3, 4, 5, 6, 7, and 8. Now, when we look at this, we were pairing up electrons as we were counting, as we were doing atoms for exactly this moment right here. The whole reason is right now. I see that this carbon has 2 unpaired electrons. It looks like these ones are paired up and those ones are paired up. What this is telling me is that these 2 electrons, this one coming from carbon, this one coming from oxygen, these 2 electrons will spend some time hanging out with carbon, sometimes spending hanging out with oxygen. Those 2 electrons are shared between those 2 atoms. And as a result, those 2 atoms are pulled right next to one another. They are sharing electrons. Same thing happens here. But I see 1 unpaired electron in the outer shell over here, 1 over there, and then 2 up here. Okay? Well, what if we took this red one here and we brought it down to the side over here, like so, and took this one over here and moved it up here, like so. Now they're no longer over there, and it's no longer up here. Oops. And I have 4 electrons. They're shared between these two. And these two have been paired up, and those two have been paired up. We'll repeat the same thing for this unpaired electron. We'll move it off to the side over here. And this blue one, we'll move it over here. Now I have paired up those 2 electrons. Their buddies are hanging out. So are those ones. They're paired up. These ones are paired up. Those ones are paired up. Looks like all electrons have a pair. That makes 3 stable atoms, all of which are sharing electrons, forming what is known as a covalent bond. Or in this case, since there are 2 pairs of electrons, we have right here a double covalent bond. And as a result, we no longer have 3 atoms, we have a molecule. 1 carbon, 2 oxygens, carbon dioxide.